All right. Okay. All right. So basically, what we had discussed last time is, we discussed that the LoRa technique for fine tuning, that is, what we try to do is we had seen earlier what is full fine tuning. That is, you have full fine tuning, and then full fine tuning. After full fine tuning, what did you see that, okay, full fine tuning is there, and then uh, after full fine tuning, then what happens is you go with the LoRa fine tuning, right? Now, a common question, few of the common concepts that we would like to discuss here is, you know, uh, so basically, in order to demonstrate what I did was, I'll open one more uh, model basically. Just hold on a second. I'll have to go and search it on. Okay, I'll just share one more screen. Right. Now, basically, what I did was, I went ahead and I actually wanted to create one model that is my own model from scratch, and there is also learning associated with that. Basically, I'm basically experimenting with pre-training of the model. So this is one of the. It is just like a GPT-2 model, but yes, I mean, I'm trying to create my own model that I will push, right? Uh, into the in to the Hugging Face maybe in few weeks or something. This is something like, I was, now obviously you do not have to go through all of that, but yes, I mean, what I did was I took the GSM 8K fine tune. Now this is from the scratch. What is happening, right? If I try to train the model from scratch, it is training. It is not that it will not train, right? And when I will basically, okay, uh, fine tune, and okay, when I will try to run it, right? Now basically what is happening, if you see, when I'm trying to run it this time, I guess it says that the total cost number, total cost number, total cost number, total number of, total number of, total number of. So it is trying to tell all of these things, right? Now, what does it means? It means
Amit,
a lot of, yeah.
just one basic doubt. Sorry. When you said you're going to, you trained your model and you're going to push it into Hugging Face. So I just want to understand, like, why do you normally do this? Like, is there anything we get by pushing our model in Hugging Face, or is there something unique we are creating by doing our own model? Like,
Yes,
I'm
there
just
are
trying to
lots of,
understand why. Yeah.
yes, yes. So basically, there will be lot of, let's say I want to create a new kind of model. I mean, now what I'm going forward, I will be basically using new architectures. I
Okay.
will be developing new architectures. Now, this is not a new architecture which I'm trying to experiment. So basically, I want to develop new architectures. New architectures in the sense we already have, like we have transformers. In transformers, we have a lot of different other things, right?
Yeah.
We have transformers. In transformers, we have seen that we can create our own architectures, right?
Right.
Right, we can go ahead. So basically what I will try to do, for each kind of problem I will try to create a different architecture. I will try to create different kind of rope, that is positional embeddings what we have. So I will try to add different logics. Then apart from transformers, I'll also try with Mamba architecture and all those things, right? So basically, yeah, I mean, the whole idea is that, I mean, I, being very much deeply rooted to this field, I want to establish a complete theory
Mhm.
around best way and the smallest model to, basically smallest model that you can run maybe in your system or something like that for your specific problem, right?
And improve the accuracy, right? That will
And
help.
approve the accuracy. And when that is the case, let's say if anyone comes to me for consulting and they say that my data should not go outside and all of those things,
Hmm.
then maybe I can sell to them,
Yeah.
right?
Yeah. But
Yeah. Right. So this is, I mean, this is something I always wanted to do. But yeah, I mean, earlier I was also roped up with lot of things. So what I have tried doing is this thing. Now, whenever you see these kind of things, today we'll try to understand when model is speaking any language, there is something wrong with it,
Black or
right?
white?
Right. There is something wrong with the model, and we'll try to understand that what is wrong with the model. This time when I try to show you, yeah. Hey, hi Balaji. I guess you can you kindly put on mute, I guess? Thanks. Right. So basically what we are trying to do is whenever you know model is trying to what I was trying to train on a logical reasoning, that is mathematical reasoning, we can call mathematical reasoning, logical and mathematical reasoning data set. And I created a model from scratch. But you don't have to do it, right? Like I said, you don't have to do it. Create a model from scratch. Now, when I'm trying to create a model from scratch, then let's say, or you can take any other model, right? So when I'm trying to create a model and I'm trying to train it, basically, I'm trying to train that model, right? Uh, so when we are trying to train that model, what is happening that, it is trying to give, it is not giving me right outputs. It is giving me some, it is repeating some words and sentences. So what is happening here? The reason being, it has yet not learned to speak, right? Now just imagine that it is a small kid who is still learning to speak, and he keeps on repeating the word he knows. So these models are very similar to that. So in the sense, English language has not been taught to this model yet. That is, pre-training has not happened for these models. Pre-training, right? Pre-training has not happened. Now, pre-training is a costly process. It is a very costly process. What is pre-training? That is, we assemble a huge amount of data from books, right? And some data from a lot of scientific journals, articles, and everything, whatever the data is present. And we assemble that data. We try to, we try to train the model saying with lot of various tasks. Those tasks can include like the missing sentence, like the simple exercises, missing sentence, complete the sentence, complete sentence, right? Complete sentence, fill in the blanks, fill in the blanks, right? And various other tasks, fill in summarization and all of those things, summarization, question answering. So there are a lot of tasks, on which basic tasks on which it is getting pre-trained. And once it gets pre-trained, it is called as the foundation model. What is this called as the foundation model? So one of the reason I am also trying to play with this, basically I'm trying to assemble my own research paper, which I'm trying to publish in some good journal, maybe down the line 2 3 months. There is, I mean, I'm trying to. Uh, so basically, the whole thing now is that you should be able to reduce the size of the model or increase the accuracy of the model, something, and then if you are able to do it by 5 to 6%, which is huge, then I mean you will be kind of, your papers will be accepted, and then obviously you make a good place in the scientific community of AI and all of those things. So yeah, I mean, then you will have to go ahead and play with the models, right? So this is what I'm trying to do. Right. Now, basically, any foundation model, then basically we'll have to pre-train and we'll have to do all sort of things. After pre-training, we'll have to create a model from the scratch. And once you're creating a model from the scratch, then what is happening, that this is called as a foundational model. This is called as a foundational model. These are the foundation models that you have nowadays, right? That is whatever the foundational models you see, llama, right? Llama, Mistral. These are the open source foundation models that you have. And hence, it is advised that you go ahead and build on top of it. You build on top of it. That is, you don't go and, uh, uh, you don't go ahead and uh, fully fine tune it. I mean, fully fine tune can have certain disadvantages also when not done in the proper way. I mean, I'll just come to it. That is full fine tuning. What happens? That is in full fine tuning, although it is the most efficient way, full fine tuning is the most efficient way, right? Full fine tuning, right? Like we have discussed, full fine tuning, it is the most efficient way. This is most efficient. But if there can be a chance, if you are doing it, I mean, if your data set is not very much balanced, it is not clean, it is having too much redundant data, you might end up, whatever the model has already learned, you might end up, making it forget what it has already learned. So basically the model is there and you full fine tune it with not so good data, you full fine tune it with not so good data, and then these organizations have been putting a lot of money and on resources in properly balancing the data, and so that they have various benchmarks on which this model should be tested and all of those things. And then if you go ahead and fully fine tune the data, although which is also very costly, so practically, I mean, no one opts for it. But yeah, there is a risk that if you're not doing it properly, then you can end up in catastrophic forgetting. Like you end up in a problem called catastrophic forgetting. Okay, catastrophic forgetting means maybe the model might even forget to speak properly. That is write properly, right? As of now, they have taught the model to speak English language, to speak English language, right? Now, just one small secret I want to tell you that, I mean, that what, why, so you might be seeing that people are coming up with lot of things saying that it is not able to sometimes back that how many R's in strawberry, right? And all of those things, how many R's in strawberry, these are the kind of questions people say that what chat gpt is not able to answer. I mean, what is an AI? I mean, it is a dumb AI and all of those things. So basically English language is confusing language. English language is confusing. It is ambiguous. It has a lot of ambiguity. It is ambiguous in the sense that one word can mean completely different with the same word. Once it has different positions, it can mean different. All of these things, and thus a lot of model resources are actually, or we can say they are occupied by the rules of speaking English only, by the rules of speaking, by the rules of understanding, by the rules of understanding and writing English. I mean, lot of huge amount of space is occupied here itself. So, and then on top of that, logical reasoning, you're trying to say that see, models we have already seen. Did you remember we trained one MB model that was able to solve some simple puzzles? So a model, this category of model, the more close it will be to mathematical numbers, more close to mathematical numbers, the more accurate and more wonderful it is going to be. More close to numbers, right? The better it is going to be, the better it will be, right? All of these things, how many R's in R, I mean, that is okay, but all of the complex calculations it is able to do, we were able to make it go through all of the complex things and all of those things. Do you think large language models can do that? No, they cannot do that. It is not, they are dumb, they're not meant to do that. you know we are actually forcing these models to do something that it was never meant for. It is meant to speak to you. I mean, it is meant to understand some things, but it is not meant to So what is actually happening as of now, if you see, there is a big huge layer what you're trying to see. What we did was, and why, if you remember now, why initial 1.5 to 2 months that we spend on PyTorch is important. So your model understands numbers. Your model understands numbers only, right? It understands numbers. It understands texts also, but through numbers. Through numbers, text, right? Correct. You can make any logic, you can make any logic your model to understand, right? Through numbers, obviously, anything, obviously, but it doesn't has to be that I don't have the proper training data set or something. Once you have the proper training data set, any numbers model can understand. Model is supposed to do that. Now, basically, what you're trying to do here this time is, this is a model, and you're trying to say that, you know what? Okay, this is what is happening inside. What is happening inside? This is text. You want that a model should understand this text here in that logic, and it should automatically build some logic here, so that it can convert all of this to understand it. And this is where it gets inefficient. This is where it gets inefficient. So I mean, its whole point being that the model, and we are wasting so many resources just on this. I mean, obviously, they are wonderful. If we have to get the summarization, we can get summarization. If you have to get uh, something like uh, text generation, they can generate the text, obviously. But the moment you now, what you want to do is, you want them, this text, to understand all of the numbers, which again becomes something, it is supposed to understand numbers, but then you're following a round route. That is, you want it to have numbers, and then you want it to automatically convert this text into numbers, and then it should understand that. So this is where this is an inefficient route. This is an inefficient route. But you know what it has done, it has brought a great business value. All of you have started spending, you know all of you have, including me, we have started spending on what? We have started purchasing AI, right? So basically, if you see, the whole thing here is not about much about, I mean, now, if you have common sense, you will also know that, okay, I mean, what we are trying to do, what AGI and all of these things we are trying to talk here. Because obviously this is inefficient way, right? The efficient way would have been a much smaller model. We just train the problem and it's done, right? But obviously the problem there it becomes is, uh, they are very tiny. The AI is not costly in that case, right? AI is not getting costly in that case. Uh, Here the AI is costly. AI is getting costly. Everyone can use it. Everyone who understands prompts thinks that they are AI engineers, you know, giving them a fake sense of achievement. And then on top of it, burning a whole big uh, hole in the pocket. I mean, you know what? So this is how it is happening. So basically, it might get busted in some years, but in those some years, all, the whole aim of any wave is to uh, get money. It may be any wave. The whole aim is to get money. To get money, so to build a perception so that public spends money. I'm not saying that they're not good, they're not wonderful. Obviously, they're wonderful, but sometimes, and hence I was saying that do not try to force your use cases inside LLM, right? They're language models, they can interact with you, right? But yes, they will have limitations until unless either we, someone comes up with an architecture, that mixes very well the text and something, text and something else, numbers, they are getting some kind of algorithm maybe. But like, I'm also very active with the research and all. So yes, I mean, this is going to take some amount of time. It is not going to happen immediately. All right. So here we are, right? So I hope, I mean, these things will help you in taking the decision in future, that, whenever you have to take the decision that, okay, you have to burst a lot of money in the AI models or what, uh, And then what is happening that, a lot of uh, people who do not understand tech, they spend up uh, burning money like hell. And they finally, there are companies being shut down just because of AWS and cloud bills. So yeah, I mean, and then the pricing of the products, it goes sky high. So all of these things happen, right? Okay, having said that, what we were trying to see here is that, full fine tuning is good, but sometimes, first and foremost thing, it is cost inefficient. It is cost inefficient, right? It is cost inefficient. And second point being, it is actually, uh, it can result into another problem. Although these models are so huge that you may end up disrupting their learning, right? You may disrupt their learning. So Balaji, do you now understand where your problem is fitting now?
Yeah, yeah. I kind of understand now.
Right. So not everything has to be solved via LLM. Now LLMs are good, but if you now you see, I mean, I see some use cases wherein people, what they are trying to do, they are trying to build LLMs and they are trying to teach it to recognize image. Now obviously there is a different model responsible for doing all of those things, and obviously there is going to be a very big barrier here, right? Because these are text models, or nowadays we have text and vision models. We'll cover these also. We'll cover one example of them. Text and vision multimodal, which we call as multimodal model, which can understand text as well as image. They have a bit different architecture, but yeah, I mean, we'll have a look. So basically, it is like, you have a car and now you want that, you want that my car should be, towing cement from one place to another place. So yeah, I mean, for towing cement, we have different tool altogether. For car, we have a different tool altogether. So it cannot be that we have a cover of truck on a car and it does the job of a truck, right? It cannot be possible. So we have these tools, and it is very important that, in today's
Anand,
world, yeah.
Anand, so for my use case, like as I understand, I should be selecting some smaller model from Hugging Face and do a do a fine tuning on that.
First prepare the data set,
Yeah,
and
yeah.
then yes,
Once
yeah,
the data is ready.
you can prepare you can try with the full fine tuning, or you can even try with QLoRA. You can even try with that, right?
Yeah.
Right. Or a better approach, I would say, if at all, I mean, I'll have to look at the rules. If at all there is a way you can convert them into pure numbers, right? If at all you can convert into pure numbers, you can simply, I mean, you will not even need a LLM model.
Yeah.
I mean,
I'll maybe whenever you're free, I'll bring my sample data. So
yeah, yeah, yeah,
see
sure.
that means
I mean, it has to, if at all, because I mean, but there is a thing that not every data set can be converted into numbers.
yeah.
I mean, this is also a problem. Although uh, I have uh, I have a belief. I mean, now basically because I'm very much interested into numbers, so I have a belief that everything can be converted into numbers. Now, this is my belief, obviously, but yeah, there is a very general belief that not everything can be converted into numbers. Uh, but yeah, I mean, I slightly bit of differ from them. I say that everything can be converted into numbers. It is just the proper numbering thing, or the proper numbering strategy that we need to use. That's it, right? uh, and if at all, for an instance, the point being that, let's say, they say that common sense. Now common sense is something, they say that, if it's raining, uh, then it automatically means the ground has to be wet. The ground has to be wet, right? So basically, yes, this is a kind of common sense. Now LLM models can be trained on this thing, yes. But yes, I mean, if really you need this thing in your problem, you do not need these kind of assumptions. These are the kind of decisions you'll have to take, right? So yes, common sense is something, obviously, that LLMs are trying to learn, and they will, as the time goes, they might, become huge. They might become uh, bulky. But yes, somewhere down the line, like I said, it's hard for me to believe that until unless there is anything very architecturally uh, something innovative apart from where we are, there will all the models will suffer with the problem of learning all of the logics, complex logics especially. They will suffer with the problem of solving complex logics, especially with text, right? I mean, they will, you can train these models for specific, for instance, I want to train a model, specifically on chemical reactions, on chemical reactions. Now, on, if I want to train my model on chemical reactions, uh, there are people and there are companies who are investing. They say that we will train our LLM on chemical reactions, that we enter compounds and it will predict the kind of reactions it has, or they will enter the final result and it will try to predict, what it has. This is one way. uh, Obviously people have budget and they do that, but a more efficient way can be, you have a simple model. You first convert these chemical reactions into some kind of numbering conventions, right? And then you feed that into model. I mean, a very lightweight model that can be trained. However, this process is tough, and this process requires someone very specialized, you know, which nowadays industry believes that what we call as a data scientist, or industry has started believing that why do we need it? We can simply go ahead and dump everything into an LLM and that's it, it's done. But however, I mean, here uh, at least 10x less cost would be saved and everything. And now what has started happening, models have started falling apart. I mean, the models are not getting very efficient and all of those things. And there is a reason behind it. If you do not understand what is happening inside the model and you just keep stuffing the model with the wrong data, you're not going to get wherever you want to, right? So these are the kind of things, we have to be careful in future. I mean, whatever the knowledge you take from here, I believe that, you can use that knowledge in your professional environment. Now, going forward, we were talking about full fine tuning can be sometimes harmful. Actually, it's not harmful, but yes, it's harmful to our pocket, right? If done right, it can be very useful. But yes, I mean, having provided that on 7 billion model, 7 billion llama model, I mean, fine tuning, full fine tuning, I mean, it is a nightmare from the cost point of view. And on top of that, we do not know on what things it has been trained on. So, I mean, there are a lot of useful things it could have been trained on. Now, so hence we had the technique of LoRA, right? LoRA. We had the technique of LoRA, and we discussed yesterday that what is LoRA and how did we use that, right? And along with LoRA, basically we have also now there is one more way. Even LoRA sometimes is heavy, although you should first try to train your model using LoRA only, because LoRA is quite efficient, and you can also train your model using QLoRA, right? QLoRA is quantized version of LoRA. That is quantization in the sense quantized version. That is, initially the model precision is stored in 32-bit, right? You can directly, without QLoRA, you can convert it into 16-bit, right? Because if you remember in LoRa itself, what I was trying to do, I was trying to load it into 16-bit. Then you would say that why not just convert it into 8-bit, or why not just convert it into 2-bit, right? No, it doesn't happen that way, right? For converting 32-bit to 16-bit, it is basically a hardware problem, right? Basically, the hardware has been made in such a way that obviously we can use the same storage locations, but with a lower amount of. Now I'm not going very deep into it, because what is happening, I mean, how transistors and how CPUs and GPUs they store value, I'll have to go into that depth. All of us have studied that Mentisa and everything in our 7th, 8th, 9th, 10th, or 11th, 12th standard, all of or maybe in our graduation or somewhere. there is a float part, and there is a Mantissa part, 16 raised to the power 2, there is a Mantissa part, and all of those things. So basically, it's a storing strategy. It's a storing strategy. So when we change from 32 to 16 bit, it's a difference in the storing strategy. It becomes float, right? And from float to brain float, it is again a different storing strategy. It is different storing strategy. That is what happens basically. Instead of, I mean, it allocates some more bits to Mantissa. I mean, obviously it has fixed amount of storage locations only. So in float to brain float, what is happening, I guess, I mean, I'll have to go back and cross check, but what is happening, it is assigning more value to Mantissa. When it is assigning more value to Mantissa, basically in GPU, brain float becomes faster to train. Can train with float also, but these are faster. These are really faster. I mean, you should always, if you're on GPU, you should use brain float. If you're on CPU, this will give you an error. You will not be able to work with it, right? Then you will have to go with the float part. And hence, GPUs are sometimes exponential faster. We have seen that 25 minutes of training, it could be completed in 1 minute and something like that. So it is because of these brain float and all of those things. So yes, we were here that 32-bit to 16-bit is a hardware decision. It is a storing strategy decision. However, when we have to scale down from 16-bit to 8-bit, basically we need to use a program here. We need to use a program. What it will do is 16-bit matrix. There is a 16-bit matrix, and it will basically scale it down to 8-bit matrix. Or you can also use 4-bit. You can use 4-bit. And hence, for doing this operation, we have to use a library called bits and bytes. Bits and bytes, which is again supported inside Hugging Face only. So if you want to scale your data, scale it to 8-bit or 4-bit, then you have to use bits and bytes. Now, what is getting scaled down here? The main model is getting scaled down. The frozen model that you have, the fixed model part that is not getting trained, frozen model, this gets scaled down. And since it is getting scaled down now, obviously what you require less memory. You require less memory, right? You require less GPU. Now, obviously, sometimes it is beneficial, you know, uh, let's say we are able to fine tune 8 billion model using these bits and bytes on a collab environment itself. Now, it has a lot of information uh, which we can obviously use of. Obviously, there is a loss of precision. Loss of precision is going to occur, right? But when it is fine tuned along with your new delta model, obviously you get the advantage. Whatever the delta model you have, delta data you have, and you train it with this 8-bit model, so you get that advantage. Whatever the advantage you have, you want to get that advantage. Again, like I said, LoRa and QLoRa will not add new knowledge to your model. They are not going to add new knowledge to your model, right? They are going to change the behavior of the model. So, I mean, let's have a look at the training part now. Okay, we were here with the LoRa part. Okay, all right. Now, first and foremost thing, what we'll do is there are few examples that I have to cover today. There are quite few examples actually. Let me pull out. Obviously, we will have to go with our. Okay, first, let's we'll try to train full fine tuning on something. It will take some amount of time. We'll have to. Okay. Although we have seen one thing of full file tuning, let's have a look at better data set this time with full fine tuning. Let's see. If not, we will spill to other next class for further things. Okay. So first and foremost thing, like I said, we have to full fine tune, right? We are not pre-training. We are not pre-training. So pre-training is something what I already told you, that pre-training is teaching uh, language basics. It is teaching language basics to a model, right? And okay, so full fine tuning, obviously we have all of those things. And first, let me prepare the model, right? This time, what we are going to use, we will use the Hugging Face Facebook Bart model instead of GPT-2. I will use a Bart model, Bart base. I will use this model. All right. Now there is a small difference here. That is, this model is sequence to sequence model. Like we have discussed earlier, that there are some models that are encoder models. It is a sequence to sequence model, like it says encoder and decoder. It has both encoder and decoder, right? So we will use these models for training on maybe a data set. We can take GSM 8K. This is the data set that we'll use. Basically, it's a mathematical and logical reasoning kind of questions. Question and answer. It is present here. So let's actually quickly do it. Although we have seen it, but this time we have to learn that how basically to use uh, the best practices of training the model. Obviously, we will be training it on one epoch only as of now, right? We'll train on one epoch, but yes, we'll try to install some new knowledge into it. It does not knows any reasoning as of now, right? Okay, let's start. First and foremost thing, we have to update it. Pip install torch and datasets and transformers, accelerate and bits and bytes, right? Let it happen. First, we'll start with the CPU only. Then later we'll switch to GPU for training, because obviously on CPU, I mean, it is going to be slow since we have brain float. So it is going to be a bit faster. we'll develop this program quickly, so that we don't waste a lot of time here. We just want to, because there is some amount of time it will have in training also. Okay, done. Then in the meanwhile, let it start. Okay, I'll import torch, import data sets from datasets, sorry, from datasets, import load underscore dataset, and then from transformers. I guess I have all of this here. Right, let me get it. Import auto tokenizer, auto model for casual LM, training arguments, trainer. This time, since it is a sequence to sequence model, so for sequence to sequence, they have provided a different trainer also. So I'll just import that from transformers, import okay, import sequence to comma. Okay, we also need training arguments, sequence to sequence training arguments. Right. GSM 8K. All right, dataset gone, done, and then correct. Now to start. Tokenizer, create tokenizer and auto tokenizer for trainer API for full fine tuning of sequence to sequence model. Tokenizer, we'll just name it tokenizer from pre-trained tokenizer, and the model, it did not load the model EOS, right? That is okay. Fetch model also, auto tokenizer model. It should be, instead of auto model for casual LM, this is going to be difference. Auto model, I guess it is for sequence to sequence. Sequence to sequence, right? LM from pre-trained, and tokenizer is, I guess, same, right? Auto tokenizer, it is already done. Okay, let's do it. Let's load our models. Okay, output dir. We need some from pre-trained. Out. What is going to be from model name? From model underscore name, and then it will take some amount of time to load these models. In the meanwhile, we'll try to load the dataset also. Right now, dataset is equal to load underscore dataset. Okay, done. Got it. And let's load the dataset. We'll train on full dataset. Okay, instead of split train, we'll go with dataset. It is going to be right main, I guess. Got it. Okay. Next is I'll generate, create pre-process function, prepare data for sequence to sequence model. Question is an input decoder. Answer is an target decoder. Okay, let's check it out. It says model inputs is equal to tokenizer of, for example, of quotient, max length, I'll keep it as 256 instead of 128 because nothing is going to be there in 128. 256 length. Okay, and then labels model underscore input is fine. Example underscore quotients. Example underscore quotient. Quotient is going to be fine. Max input and truncation true. Okay. Padding max length. Got it. Tokenizer. Example answer. Max length max. Source length and target length. We'll increase this. This I will keep it as 256 only. Truncation padding. Model inputs label. Label inputs and done. I guess yes, this is right. Model inputs, then tokenized datasets is dataset.map. I mean, the whole data is mapped to this. The dataset gets mapped to this. Yeah. As of now, we will not be splitting. We'll try to train on complete one. But yes, I mean, we should split ideally. Now we have to prepare the arguments. Create sequence to sequence training arguments for trainer. Okay. Output directory, full fine tune. All right, we can take this as my output directory. Output underscore dir is equal to this. Number of epochs, I'll keep only one. Right. Per device, batch size 8. Okay, 8 warm up steps. Weight decay 0.1. Save total limits. Logging dir. If we want to log, it is okay. As of now, I will not. Logging steps is required 10. Evaluation strategy, correct name is eval strategy. Steps, eval underscore strategy. You want to keep it on epoch or steps because we are having just one epoch. So I want it to be evaluated at every steps. Save steps, eval steps. Do you want your model to be saved in every 1000 steps? Ideally, it will have around some 1500 or 2000 steps it will have. So we can have save in every some 500 steps if you want. Report to predict with generate. This will be very costly function if we predict with generate important sequence to sequence, but let it be so that evaluation can happen. And report to none is fine. Logging dir, batching. Okay, done. I guess this is fine. And next is basically, okay, sequence to sequence trainer, but we will have create sequence to sequence trainer. Collector. This is standard, basically for dynamically padding the inputs and labels. Data collator, sequence to sequence model is equal to model training args, train and test, eval dataset, tokenized datasets, tokenized dataset, but we did not split in train and test. Tokenized dataset. Hold on, let me check. Tokenized underscore dataset of train. Okay, fine. Tokenizer, data collator. That's it, I guess. This should be fine. And trainer.train. We'll save it later on. Let's start the training as of now. It is going to take a lot of time. So if the training is successful, we'll switch to GPUs. For one epoch, it will still take some 10-12 minutes. I mean, here it is going to take few hours, I guess. Mm -mm -mm. Okay, I guess training has started. Let's see how much time it is showing. 9:35. It might take, it might show few hours. At least one epoch should, one data should complete. One step. Again, ways we can switch to GPU. I mean, we'll not waste much of the time. Let's switch to GPU. Change runtime table GPU save. We'll have to reinstall all of those things again. It has hanged for some reason. Okay, let me quickly install these things. Okay, done. Okay, it is going to take at least 11 minutes to train. Okay, till the time it takes 11 minutes, we have theory to cover, which we'll cover. And then we'll switch to basically. Okay, sure. It will keep on training. Oh, no, it has taken, now it has updated 45 minutes, which is going to be too long. So what I can do as of now, I can limit its training range, 45 minutes is going to be too huge time. So length of train 7473. Okay, 7000 we have. What I'll do is I'll reduce to 1000 only. Let me do that. Select only random 1000 data. Select random or 2000. Now you should try to train it complete. Select random. This you can run in your laptop also. You can set this laptop in the night, and by the morning you wake up, the complete training will be done. Select random 2000 data sets for training. Dataset full, dataset shuffle. Where is my dataset? Dataset is this. And let's try to see if it happens. Main, uh, main sample of usage, main, right? Shuffle has no object. Select. Hmm, because the type is not type of dataset underscore full. It's dataset dict. It's dataset dict. Select random 2000 data points for training. Okay, we have this, but we don't have test, I think so. It still has full. Hold on. Load dataset. Dataset of train. Length of dataset. 2000. Okay. Trainer.train. Tokenized dataset. Now tokenized dataset train. Length. It doesn't have train. This will not work. No attribute select. Shuffle is fine, but select random iterate. Select 2000 data points from dataset. It's in data tech. Select is not available. It is again and again using select dataset of train, dataset of test. Test is this and train is this is train. Okay, 2000. That's fine, right? Reprocess again. Okay, again, and then tokenizer dataset of train. Let's check at least our keys are available. Oh, train. Okay, got it. And test. Test. Got it. It's not required. Not required. Trainer dot train. Okay, this is 3 minutes as of now, but I guess it will increase to 7-8 minutes. One way of decreasing the time is also you decrease the maximum length of it. If you go ahead and reduce the length, then obviously it will consider only smaller values or smaller sentences, and time will be reduced drastically. Okay, just will let one step complete. Got it? Yep, let it finish now. It will take 15 minutes. Now it has started showing the right time. 12 minutes, yes. 12 minutes is the right time. Okay, got it. Now, basically, what we were talking is, first we have to understand, we have this. This is full fine tuning. Let it happen. Then we will follow the LoRa fine tuning. In LoRa fine tuning, we have this LoRa config, and we have a few of the options that are present in LoRa config, right? So let's first discuss that what are the options of this LoRa config. The first and foremost thing is the rank. Now, if you remember rank, I have already did show you. I'll just open it. Yeah, if you see rank, now 32 by 8, 8 is the rank. If I change this rank 10, then obviously my trainable A and B changes, right? Yesterday we had a discussion that what is happening when I'm choosing this LoRa trainer. So basically when I'm choosing this LoRa trainer, what is happening is it is creating two matrices, and then the output is basically W into X. First, this is frozen, and W into X. X is my input. W. So basically, this is getting multiplied, and then A into B. These both are getting multiplied with the input. See, basically what we have seen. And then this is how what is happening. So this new extra things are trained only, right? These new parameters are trained, right? And then frozen, the original model is not trained. And what happens in QLoRA? We further strip down this model, or we reduce the precision of this model, right? Instead of 32, I mean this, not this 32, right? But instead of 32-bit precision, we may choose 8-bit or 4-bit. 16-bit is not QLoRA, right? 16-bit you can do in LoRa itself. I mean, you either do 4-bit or 8-bit in QLoRA. Then basically there is one more point, that what is happening when you are running the model in training phase. We have input data, we have correct labels, we have forward pass, right? That is in the sense training is happening, it is calculating the loss, and then it is updating your gradients in these two matrices only, not in the original matrix, right? Not in the original weights. Update only A and B using gradients. Got it? Now, when the model is running, then basically this will be present. Your original model is going to be present, but along with this, these two matrices are also going to be present, right? So these two will also be present along with your model, right? So basically your model, original model is going to be there, but along with it, these two matrices are going to be there. So hence it means some amount of memory overhead will be there, in the sense only if you require some additional information, or not information, some additional behavior you want to be added to your model, then only you should be adding this thing. What can be additional behavior? What is additional behavior? Now let's say your existing model like DeepSeek or something, it already knows how to query, into your database, and now you want to add small these peft models on top of it, right? That know to specifically query over MongoDB, right? This is change in the behavior, but provided it should already know how to query. This is change in the behavior, right? This is change in the behavior. Uh, we are not teaching new information. We are just teaching it some strategy, or the data is automatically getting output in some non-JSON format. We want all of the data. Whenever we say that you output me in the JSON format, it should tell me in the JSON format. It will tell me in the JSON format. So nowadays, most of the models, if you go ahead and you check, you will get the list. Most of the things, you will not get much of the information about pre-training. But yes, I mean, if you go ahead and read their release papers, you can see the pre-training information of some llama models or something like them. Not all of them release all of this information, right? Because that is a confidential information, and that is what everyone is fighting for. Now we have trainable A, trainable B, right? And then what is happening, like I said, in inference, that is in the running phase, what happens, there is new unseen input. It is frozen weight plus trained B into trained A, final prediction. So basically, yes, no calculation, no backward loss, and no weight updates. Obviously, in training, it doesn't happen. So basically, it goes through your original model, as well as the new trained small two matrices are also getting involved. And hence what happens, this information is additional information, it is able to. Now you might say, why we are not able to add this new information into these models? However, you see, adding information is not that easy. First you have to teach your model how to speak, how to learn, how to read, how to write, right? And then you have to add some information on top of it. However, in this case, I mean, these are very small things. So what we are trying to do, we are just trying to, it already knows how to read and write, right? So you don't have to teach it. You just need to add certain information, extra information about uh, any other thing. So you can do all of those things. Great. So this is what is called as, and this is what we have basically in the PEFT models. Now, okay. And this is what we were actually originally we were talking about, the rank, right? So rank is basically, it is a dimension, right? It is a dimension of the trainable LoRa matrices, right? And one of the most important part, right? So rank is something that is very important. It is the dimension of trainable matrix, trainable matrix, right? Then we have is there is one more parameter, I guess, LoRa underscore alpha. Basically, it is actually a scaling factor that adjusts the magnitude of the LoRa. I mean, you can assume it as a knob, as a volume knob, right? The final adjustments are applied to the original model, right? A common practice is that you set your LoRa alpha to be twice the value of R. I mean, whatever the value of your R is, let's say if it's 8, you set it to be 16. If it's 16, you set it to be 32, right? It helps to stabilize the training basically, by preventing the smaller weights from excessive learning. I mean, this is all I got from the documentation, but yes, I mean, there is more of it which we can dig ahead, but yes, I mean, it is not needed. So basically, LoRa underscore alpha is a kind of, scaling factor for the training. The third is LoRa dropout. Dropout is basically what happens in the dropouts. This is also one topic I did not cover when I was teaching. So the basics of AI. So dropout, what happens, if there is this uh, weights you're learning some weights, you're learning some weights, you have some weights, this is how your weights will be, right? Now, sometimes what happens, dropout is recommended usually so that your models do not memorize any pattern, in the sense what we tell that, what, out of these we have 8 these weights and biases, we give dropout to be 10% out of 8, or if it is out of 10 basically. So if, let's say there are 10, so out of 10, 10% of the weights should automatically be removed. So basically out of 10, every one will be removed. So what is going to happen if it is removed? So basically, if, I mean, this is just luck by chance, that if there is any uh, learning by heart happening, it is trying to memorize anything, that will not happen basically. So in this way you can increase the number of epochs, and also make sure that, it is not memorizing. I mean, it doesn't memorizes your data, because if it will memorize, it will only work on your training data. On unseen data, it will not work. And then the next thing that we have is the bias. Bias we have already seen basically, we have learned. So bias basically tells, if, bias is a parameter, if it is telling that, if, the targeted, I mean, it is kind of a parameter that says that what needs to be trained, right? Let's say there are three options to it. One is basically none, one is none, the other is all, and the third is LoRa underscore only. So basically, when you are training your LoRa weights A and B, right? Uh, what happens? It is not going to touch any other parameters, and which should happen basically. Now, if you say all, it will go ahead and try to modify the original bias parameters as well as the LoRa weights. I mean, you should always use none and LoRa only, right? Whatever the new has been added, basically for A and B matrices only, whatever the biases are present in A and B, it will go ahead and update these only, right? However, there is one very important parameter that we will have to see maybe in the next session, but I'll just get that is target modules, target underscore modules, and this you will see very frequently. As of now, we did not see it. Target underscore modules. Target underscore modules is actually the list of layers at which you want your LoRa adapters to be added, at which LoRa adapters should be added. So we have to specify them. I mean, we will have to specify, which of the targeted modules are available. So we'll have a look when once we are there. Like, as of now, I guess it was not done. For our next exercise, we will need it. We will need all of these parameters, and our model has been learning quite well. It is still some 7 to 8 minutes. Right. Okay. There is one more, I guess, which we will be using, and the next one is task underscore type. What task are you using? So in task underscore type, we have three kinds of task. And next is task underscore type. Right. In task underscore type, we have basically three tasks. Three tasks. Obviously, one is casual LM for decoder only. For decoder only. Then first, second is basically sequence to sequence, what we are using as of now, right? Sequence to sequence, sequence to sequence. And the third is basically sequence classification. For classification tasks, I mean, so in decoder or encoder, right? These are basically the things that we are using. Either it will be encoder decoder model or it will be a decoder model. So either one of them will use in either one of them, right? So let's wait till the time, I guess it is more, what, 7 minutes. Okay. And then what we'll try to do is next example is going to be, we will be training a small LoRa module. Sorry, LoRa we have already seen, that is QLoRA, quantized LoRa, right? Let's give it some time. In the meanwhile, what I can do is trainer.train, and I can just write down, program so that we can test few samples for this. We can just take some inputs, prompt, uh, to run some code to run some samples on the trained model. Right, we can get the first 5 questions from the test and then we can try it out, correct? Generated tokens model, what does it say? That's now this is not going to be a very perfect training as of now, but that is okay. Let's see, what output is, and based on that output we'll judge that what went wrong with our training. Obviously the training is not that something has gone horribly wrong. There will be it will not be making accurate calculations. Obviously with one epoch you cannot assume to it will start making the right assumptions. There will be some hallucinations, you know uh, hallucination, because obviously it did not learn the things, and then on top of that this is a very small model. It has less learning capacity. It has been trained on various other tasks also. Let's see what Bart base has been trained on. Bart base, they're not providing any information, but yes, we can go to the loop of fine-tuned versions. Spaces, audio editing. It has 53 models, adapters, 53 adapters, and fine-tuned 426 models. Yeah, dataset information is not present on which dataset it has been trained on. Okay, I guess more 3 minutes. I guess last epoch, maybe. There are a few more. And the loss has really come down. So this is a good sign, but yeah, I mean the data set is pretty complex. If you go ahead and check the data set, it is a complex data. It is not a simple data. I mean, it is pure mathematics. Okay, all right. Done. I guess last epoch is pending. Okay, let it finish. All right, done. Let's test. Device is not defined. Let's device. Device is equal to CPU as of now. Device is equal to CPU. Expected, but found at least. Okay, sorry, it is CUDA. We are on GPU. Okay, generated. Janet's duck lays 16 eggs per day. She eats 3 for breakfast every morning and makes muffins for friends every day with 4. She sells remainder XYZ, and let's see what it has. The Janet ducks lays 16 eggs per day. She eats 3 for breakfast every morning and bakes. She sells 4 egg. So it has tried to make a calculation. Janet makes. Now the same problem, I do not know if it is correct or not. We'll have to see. It says 24 is the right answer. Rob takes two bolts in blue. Now you can go ahead and I don't think so they are going to be right. Okay, James decide to run 3 sprints 3 times a week. He runs 60 meters each sprint. How many total he runs in week? Yeah, I mean this is the wrong one. 60 meter each week, right? That is 180 each week. Right. So, like I said, at least it has now. Uh, I told you the problem. The problem is, you know, it has learned to speak the mathematical language. This is the first step. Like I told you that these models, what these models are language models. Now, what you're trying to do is you're trying to teach maths or logic. Then this is the two-step process. Now, but as you go with the more data set, it will learn. You know. Uh, 2000 is too less. Just go ahead and train with more data sets, and it is going to learn. Now it's a problem for you, right? We just trained on 2000 data sets. Go ahead and train on all 8000 data sets, or at least try to train on 5000, at least 5000, right? And see what happens. You'll see that most of the data sets, uh, it starts setting up properly. Then on top of that, what we have done, it is, I mean, at least able to, the size of the model size is very small as of now. It is Bart size, Bart base is, I guess, some 250 million parameter model. So yes, but still it has done a very decent job, right? We are able to get all of those things. Then you should go ahead and, modify the learning rate. You should go ahead and modify the learning rate and try to experiment with that. Batch size, right? Batch size. On third, you can go ahead and try with better models. You can go ahead and try with Bart large. This is but Bart only. If you want to try with more bigger models, let's say there is like I guess we have Llama 1B, Llama 3.21B. You can go ahead and try with this, but this is a casual LM problem, right? You will have to follow the casual LM approach. Sequence to sequence will not work, right? So use a casual LM approach instead of sequence to sequence. I have already given you one program using casual LM that will work. Training arguments, I guess this is the one. Labels, input IDs, correct. This is the one. This will work. Casual LM, right? This will work. Instead of GPT-2, just carefully do this and it will work. So yeah, I mean, depending on the model, you'll have to change it, right? And this was a very good training actually, and it ran luckily. we have chosen the right data set. If I mean, if I would have chosen 1500 or 1000, I mean, maybe the result might not have been that good. But yes, I mean, I'm glad that you're able to see some good results. Okay, so now what is the next step? Okay, what we did was we tried to train full training of the model. This was full training of them, right? Full training. Next is full training. That is addition of new knowledge. New knowledge, new skill has been added. New knowledge plus new skill has been added, right? Wonderful, right? Now, next is obviously, uh, what if I want to fine tune 3 billion model or 7 billion model, right? Then obviously what you can do, these models are already very huge, right? You can just write your delta new behavior, you can just add your new behavior. Again, we need to remember no new information will be added, new behavior will be added. So for demonstration, let's say I will try, one model I will try that it is not giving me the output in the correct format, let's say in the JSON format. Although this is not a good example, but I will have to brainstorm a bit more, so that I get more good examples. Uh, I mean, this example was quite good, but yes, I mean, this example is not good that, I'm not getting the output in the JSON format, but yes, I want my output to be in the JSON format, right? So basically, what we can do is, we can just fine tune the model, and with uh, this QLoRA fine tuning, this will start happening right now. So let's start with QLoRA fine tuning. At least let's have one small toy example, and then we can have a big example later on, maybe. you know so what happens? QLoRA, again, a quick refresher I will give. We just discussed it today only. I just gave you small example here. QLoRA, right? QLoRA is quantized LoRa, quantized low rank adaptation, low rank adaptation. Now, what is going to happen that when the model is too huge to load even in 16-bit, right? Even in 16-bit precision, model is too huge. Then what you do, you can load in 8-bit and 4-bit. And you do this using a library called bits and bytes, bits and bytes, right? On top of this, one more small addition I'm going to make is I have been using Trainer API as of now. Trainer API is very robust API, but a more easy API to deal is SFT Trainer, right? SFT Trainer. And what is the difference between Trainer and SFT Trainer? Trainer can be used for any kind of data. SFT Trainer is only used for chat data, or you can say large language models only, LLM only. So it reduces a lot of things, like all of that data collateral and all classes I was making, functions I was calling. I don't have to use any of them. It is very easy to train through SFT trainer. I just need to prepare my input and output, and that's it, I'm done, right? I just have to pass it to SFT trainer. And since most of the data, it is going to be your, in the chat format, most of the things. So SFT trainer is further, it adds further a bit of more, actually a lot of more complex easiness to our fine tuning, right? So let's do it this time. What I will like to fine tune is, I want to fine tune a Gemma 2 model, that is from Meta. Let me go to Gemma 2 model, Gemma 2 billion. You will actually have to, get it accessed. You have been granted access of this model. You just have to click on terms and conditions, right? And I do not know if this is already here or not. Okay, they have already hosted the model, and you can just see, right, a Python program to print 10 numbers. See, 2 billion model. I mean, it's a very small one, and it has given the right thing. And not just that, it is actually encoding in this. 2 billion is very small. I mean, and merges, quantization, and you can go ahead and see the spaces, people have been using it. And there are other good releases also. Accelerate is something we have to discuss as of now. I mean, it is a pending topic. Right. Anyways, let's first try to have a QLoRa implementation. Okay. So this time I will again take all of those things, import all necessary imports for QLoRa fine tuning. Let's see, whatever we have to do it, we'll do it. And this needs to be installed. This time TRL has to be installed on Colab, but a specific version of TRL has to be installed. So we'll take this TRL. Okay, and TRL also. So I'll just go with pip install TRL is equal to 0.12.0. Although TRL is already here, but we need this specific version. You can go ahead and even search for any good data set for fine tuning. LoRA data set, algebra, LoRA, all novels, flux LoRA data set. So it is not that using this LoRA, a lot of skills can be added. That includes some mathematical reasoning skills and all of those things. Also, actually, we could have tried training QLoRA on this GSM, this thing also. We can try fine tuning on this data set, but I do not know. I doubt this data set is already present. We can try whatever my question was. I can just try gnet stuck. Janet market $26. Answer, Janet makes 12 at the farmers. And what my says 24. Right. I do not know the right answer. So here it says lays 16 eggs per day. She eats 3 of breakfast every morning, makes muffin for her friend every day with 4. She sells the remainder at the market $2. How much in dollars? Right. So eggs laid eaten 3, 16 minus 3, eggs used, no, so it missed another 3, 16 minus 3 should be the answer. Eggs used, eggs eaten, she eats 3 for the morning breakfast and bakes muffins for her friend every day with 4. So 7 are lost every day. The information it has missed. 13 too, right? What about the muffins she made? So include the muffins made in your calculation. Again, rethink 26 only. She uses 3 for big and 4 for muffins, leaving 13 each day. 16 minus 3 minus, it is not reducing 4. The 4 are used for muffin. It should be minus 3 and minus 4. This time it has done right. Tells 9x, 16 minus, okay, I guess, yes. 2. So you saw, I mean, it was not pitch perfect, but yes, I mean, it is fair enough. Right. So here I will try to, as of now, I'll not train with the same data because it already has been trained on similar kind of many such data sets. So we'll not come to know that, what was the data even before, or what is the value it has added later on. Now, okay, TRL. So as of now, I'll stick to our JSON example. You can try with this new data set. I mean, you can try to train or some other data set basically. Model underscore name equal to Gemma. Gemma to IT. Okay. Now the next point is we need to create some data set, that is, we'll have to create some imaginary data set here. So I need some data set. Mm, 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 mm. Data set creation. ChatGPT. I want to create sample data set that is in form of instructions, context, instructions, and response. Right. In context, I want some data, then and response should be that data gets converted into a JSON format. Mm, 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 mm. Okay, I lost my prompt, I guess. And create create a JSON Python program for creating JSON dataset where information is present in context, and training dataset response should convert that information into JSON format. It is not generating data for me. So it is already assuming that I have some context.txt, which I don't have. Okay, I guess for this I'll have to then, get some data set from some place. Okay. Anyways, what we'll try to do is, for now, we will use the same data set as of now, although I'll try to use same data set. So most of my program also will be reusable actually, I can just go ahead and use same data set for QLoRA fine tuning of Gemma to 2B IT with 4-bit or with 8-bit quantization. It has taken one data set which is already present. This data set is very common and it is already present. Data set GSM8K. Load format, solve example question, input. Where is input and output? Input and output labels. The model tokenizer, auto tokenizer. Prepare the model, LoRa config, load dataset, dataset name, and example format. Okay. Dataset map. All right. Example, we can format it as and solve the following question and answer. But we need to provide the label also, the target. Dataset, formatted dataset, tokenized dataset. Tokenization, it will automatically perform here. No, I don't think so. Model name, trust code, tokenizer. It is assuming it will auto tokenize. Trainer dataset. It is automatically taking for SFT dataset, formatted dataset, train. Use the text field created by data text field text, max sequence and tokenizer, trainer. question energies, we can format it as question and answer. Mm, 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 mm. What about the targets in bits and bytes? In this program, why are we should identify inputs and outputs for SFT trainer. Train contains text for which combines questions and answer into math problem field text. Trainer to use as the input for training. Trains PEFT model. The training involves minimizing language is called output dir. Okay, so basically it is taking as one only. It is either we could have provided via masking also, but I guess that is fine. Let's try. Access. Okay, that's a notebook login. Here basically you'll have to take your token here. So I already have my token here in my system. Okay, right. Now just wait. Basically, I will have to walk you through this whole program. Although the program is pretty same what we have used. First we used auto model for casual LM from pre-trained. Then we loaded the tokenizer model. It is automatically now loading the model, right? Now we have already specified that we need is 4-bit quantization, although I asked it for 8-bit quantization, right? This, let's run this time and then we can change it for 8-bit quantization also. Auto tokenizer, all right. And then the same LoRa config. You just have to format your data set and you just have to prepare the training arguments SFT and you just have to train. So it has started to load the data set here. Once I mean we are sure that the training is running fine, we can switch to GPU. In GPU it will be even faster. Mm, 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 mm. Gemma 2 requires brain float 16. This training is going to crash. And we will have to switch to GPU only. Let's see. Okay, I'll do one thing. I'll load it into the GPU directly. There's a mismatch in the labels actually, but this is just a warning. It's not that it will not train. So it is showing me 2 hours, I guess. 2 hours? Yeah, 2 hours of training. It will have to select a smaller data set, or you can try to, fine tune it. The reason being very simple that this is, and I also made a mistake. Mistake being that I loaded it into 8-bit. So 8-bit, even if I load it into 4-bit, I mean the data set is too huge. I need a different data set basically. It needs to be cancelled and reloaded, I guess, because yeah, okay, let it train. We won't be able to finish the training, I guess, in this session. So going forward, what is the next path forward? What all topics we need to cover after this? So we have quite a bit covered on fine tuning part, right? We will cover 1 to 2 very good examples on fine tuning. I mean, although we covered one good example today, but now we will have to cover on SFT, that is, sorry, LoRA, QLoRA, right? We will go with QLoRA fine tuning. We'll need one fine tuning example then later on. Next is basically after QLoRA fine tuning we have done, we will have to, start with our RAG journey, retrieval augmented generation. That is retrieval, and this is where augmented generation. So for this, we will use the RAG and embedding vectors and all of those things, then attaching agents to them. RAG is basically you have a model and you have your external data set or database, and you are connecting your model to external data set, and then you are so almost I would say 75 to 80% of the use cases are RAG dataset as of now. So we have done enough of our fine tuning job, right? We will cover one more example, maybe starting next session. You should put your hands on it. And then from RAG itself, we will continue with the other things of like agents and MCP server. Agents, we'll cover all kinds of agent. Don't worry about it. Agents, MCP server, and then MCP server agents, and here we will cover with graph rag also, graph rag, and there will be one specific session basically for RLHF, right? Let us, because let us actually bump the problems here. RAG is something, lot of problems are faced on RAG. I mean, how do you need to fetch images? How do you need to fetch texts? And what to do when you are fetching? Because the model has the skills, but you need to add now external knowledge. What we have learned so far is using QLoRA, right? Now we will try to utilize the model as much as possible, right? We have tried to learn QLoRA. QLoRA is for adding behavior, not knowledge. How do you add knowledge? You add knowledge using RAG, using RH, RAG. Various ways, tough thing to master, easy thing to build. What does it means? Anyone can build it and have 70% accuracy. Anyone, go ahead and there are 5,000 articles present on, but very tough to build with 95% accuracy. Very tough, right? Okay. This is something here we will come, and then here itself we will have RLHF, etc., various other things, right? We'll try to learn various other things, right? I do not know the status of this training. I'll keep it running, right? Let me see where it goes. I do not know how much time it is demonstrating. It is this time. It has time has increased. It is 3 hours 47 seconds. I'll have to stop, or I'll have to bring a better example on the table, basically, wherein we can finish the training on time, right? So I will come up with the JSON example, because this is how I was also practicing, and JSON, or the second example is when you have huge amount of corpus, how do you fine tune the model so that it is able to hunt down the right information, right, for you. So please practice it, and going forward next we will have one more fine tuning example of text, and later on we will have one fine tuning example. But I don't think so we'll have enough memory for that. I wanted to show you for at least for multimodals, but we will have one example of multimodals. Multimodals are images and text, right? Team, anything, any doubts, anything, any comment, anything to add?
Anand, just one doubt. When you said RAG, it is only for text or it is also for images and other?
Images also.